So, ang title po namin ay Gas Chromatography po.
Ito po ang background po namin. The first publication on gas chromatography, also known as GC, was in 1952, while the first commercial instruments were manufactured in 1956. James and Martin separated fatty acids by gas chromatography, collected the column, effluent, and titrated the individual fatty acids for quantitation. GC has advanced greatly since that early work and is now considered to be mature field that is approaching theoretical limitations. So, what is gas chromatography? Gas chromatography po is an analytical technique applicable to gas, liquid, and solid samples. Example ay mga components that are vaporized by heat. So, anything po siya na maaaring ma-vaporize like water po, yung mga ganyan po. If a mixture of compounds is analyzed using gas chromatography, each compound can be separated and quantified. So, if mag-analyze po natin siya ng gamit ang ating GC, ma-identify po natin yung mga compound na kasama po doon.
So, how does it work? A gas sample is collected and then it is introduced to an inert gas stream called a carrier gas. It moves the gas sample through a column or series of columns where the gases in the sample are physically separated. So, in here, the sample are dissolved in solvent and vaporized in order to separate the analytes to distribute the sample between two phases. It is the stationary phase and the mobile phase. The separation of volatile compound. So what is volatile? Volatile is the compounds that is easily vaporized at a room temperatures like heptane, acetone, or methanol.
Methods to isolate analytes from food for gas chromatography analysis topography works. One of the simplest methods of isolating volatile compounds from food is by direct injection of the headspace vapors above a food product. There are two types of headspace sampling: static headspace sampling and dynamic headspace sampling. Static headspace samples are heated and agitated at a set temperature for a set time, after which a liquid of the headspace gas is analyzed by gas chromatography to determine the concentration of the analyte of interest in the headspace, which can then be related to the concentration in the original sample. Dynamic headspace sampling. Dynamic headspace is an extraction technique used to concentrate analytes from a solid or liquid sample. The sample is heated and agitated in a sealed vial, and the headspace above the sample is purged onto a solid sorbent tube. The solid sorbent tube is then thermally dissolved into the gas combination.
Static headspace sampling, used extensively when rapid analysis is necessary and major component of analysis is satisfactory. So, ang static headspace sampling po ay typically used para ma-determinate yung mga volatile at semi-volatile analytes sa liquid at sa solid matrices. Next po is dynamic headspace sampling. The sample is purged with an inert gas such as nitrogen or helium, which types volatile constituent from the sample. So, ang dynamic headspace sampling naman daw po ay ginagamit po para ma-extract po yung ma-concentrate from solid to liquid sample po. Yun lang po.
Okay, game. Distillation methods. Distillation processes are quite effective at isolating volatile compounds from foods for GC analysis. Ang distillation method po, ito po yung pagpaprocess ng nag-i-involve ng liquid sa vapor na nagko-condense back to liquid form po. Solvent extraction. Solvent extraction is often the preferred method for the recovery of volatile from foods. Ang solvent extraction naman po, ito daw po yung pag-remove ng solute component from a solid using a liquid solvent. So, ginagamitan daw po siya ng liquid solvent. tinatawag din po siyang leaching or solid liquid extraction. Ang solid phase extraction, the extractions discussed above involve the use of two immiscible phases, water and an organic solvent. Ang solvent phase extraction naman po, or mas kilala din bilang liquid-liquid extraction, ay method daw po na nagse-separate ng compounds or metal complexes based on their relative solubilities in two different immiscible liquids. Madalas daw po ito ay water tsaka organic solvent.
Tools and equipments used in gas chromatography. So, kakunti lang po ito at mostly ng mga sasabihin ko po ay makikita nyo sa part of a machine. So, common gas chromatography consists of carrier gas system which ito po ay nag-aalaw sa subject or sample at sa gas po natin para mag-travel into the machine. So, next po is injector or syringe which we use to simply inject the sample to the machine. Note, the syringe that will be used throughout this process po should be cleaned after use with a methanol or be replaced with a new one. And next po ay GC column which serve as a passage of the sample and gas. So you can see a part of it po na naka-coil inside the chamber po which is needed po natin to maintain a certain temperature. And lastly naman po is a detector or data processing unit which give us simply the reading or the result of the sample. And para nga po pala sa carrier gas na ginagamit po natin dito sa process na to, we use in this process generally a permanent gas with a low or negligible absorption capacity. So it won't affect the reading of the sample. So yun lang po. Thank you.
Food application of gas chromatography. Many foods have active enzyme system that change the food product's composition. This is particularly clear in the field of flavor work. The inactivation of enzyme system through heat temperature, brief heat processing, freezing of the sample, drying of the sample, or alcoholic homogenation may be required. Madaming pang pagkain ang na-active ng enzyme na naka-apekto sa food production. Ito ay kadalasan sa flavor ng pagkain. May mga process tayo para mahinto ang pagiging active ng enzyme through high temperature, heat processing, freezing, at marami pang iba. During the production of the sample, the food may experience microbial growth or chemical reaction. False peaks on the GC frequently occur from the chemical interaction. Thus, the sample must be kept in an environment where degradation won't happen. Certain chemicals such as sodium fluoride, thermal processing, drying, or freezing storage frequently suppress microorganisms. Ang food ay nagkakaroon ng pagtaas ng microbial o nagkakaroon ng chemical reaction. Para hindi po ito magka-degradation o mangyari on the process of GC, mapapanatili natin to sa pamamagitan ng hindi natin aalisin sa isang environment para po hindi ma-stop ang pagpaprocess.